Assalamualaikum warahmatullahi wabarakatuh. And good day everyone. So we are group 14 and today we will present our engineering statistic project entitled Statistical Analysis of the Relationship between Solar Irradiation and AC Power Generation in Solar Power Plant. My name is Hanin Srina binti Muhammad Helmi and together with my teammates Ahmad Rais Salahuddin and Muhammad Nabi Iman, we conducted the study using real engineering data and Python statistical analysis. Our presentation will cover the engineering problem, dataset, statistical analysis, findings, engineering implications, and conclusions. So, engineering problem and objective. Solar photovoltaic systems have become one of the most important renewable energy (RE) sources worldwide. However, one major challenge is that their power output is highly dependent on weather conditions, especially the amount of solar radiation received. When solar radiation changes due to clouds or seasonal weather, the AC power generated by the solar plant also changes. This fluctuation can affect grid stability and energy management. Therefore, the objective of our study are to investigate the relationship between solar radiation and AC power generation, to apply descriptive statistics and data visualization, to perform hypothesis testing, and finally, to develop a simple linear regression model that can predict power generation. Next, dataset source and methodology. For this project, we used a solar power plant dataset obtained from Kaggle. After data cleaning, we selected 50 daytime observations because photovoltaic system only generate electricity when solar radiation is greater than zero. We analyzed three variables: radiation, which is our independent variable, air temperature, which represent the surrounding environmental condition, a third system production, which is the depending variable representing AC power output. The data analysis was performed entirely using Python in Jupyter Notebook. Our methodology consists of five main steps. First, data cleaning. Second, descriptive statistics. Third, data visualization. Fourth, hypothesis testing. And fifth, simple linear regression. So next, this table summarizes the descriptive statistic of our dataset. The average solar radiation is 43.32 watt per square meter, while the average AC power generation is 248.13 kilowatts. One important observation is that the standard deviation of system production is 337.54 kilowatts, which is relatively high. This indicates that the power output varies greatly throughout the day due to changes in weather conditions and solar radiation intensity. Overall, the descriptive statistics show that solar power generation is highly variable and require proper monitoring.
Here are the data visualization. The histogram shows that most power production value are concentrated at low to medium levels, while very high power output occur less frequently. The box plot indicates that the radiation data has no significant outliers, showing that the cleaned data is reliable for statistical analysis. Finally, the scatter plot clearly demonstrated a strong positive linear relationship between solar radiation and AC power generation. Solar radiation increase, the AC power generated by the solar plant also increases almost proportionally. To statistically verify the relationship between solar radiation and system production, we perform a hypothesis test. The null hypothesis states that there is no significant relationship between solar radiation and AC power generation. The alternative hypothesis states that there is a significant relationship between these two variables. We use a significant level of 0.05. The statistical analysis produced a p-value less than 0.05. Therefore, we rejected the null hypothesis. This means that there is a sufficient statistical evidence to conclude that solar radiation significantly affects the AC power generated by the solar power plant. Okay, we move to the regression analysis. A simple linear regression model was developed to predict AC power generation based on solar radiation. Our analysis showed that the regression slope is 5.4, meaning that for every 1 unit increase in solar radiation, the system production is expected to increase by approximately 5.4 kilowatts. The regression model also achieved a high coefficient of determination of R squared value, indicating indicating that solar radiation is a strong predictor of the plant's power output. This demonstrates that linear regression is an effective method for estimate future power generation. Okay, we move to the next presenter.
The findings of this study have several important engineering applications. First, energy storage system can be used to store excess electricity during periods of high solar radiation and supply power when radiation decreases. Second, smart inverter control can reduce sudden fluctuation in power output, helping to improve grid stability. Finally, our regression model can serve as a foundation for AI-based forecasting system that predict solar power generation using weather information. These applications contribute to more efficient renewable energy management and more reliable power system operation. In conclusion, this study successfully demonstrated that solar radiation has significant power relationship with acid power generation. Descriptive statistics, data visualization, hypothesis testing, and regression analysis all supported this finding. Although our study was limited to only 50 observations, the results show that solar radiation is a reliable predictor of photovoltaic power generation. For future work, larger datasets covering different seasons could be used, together with additional variables such as humidity and wind speed, to improve prediction accuracy using multiple regression or machine learning techniques. Thank you very much for your attention.